ጠፍቷል እሱ። ምንም ቆይ ልደውል መሰለኝ። ይቆራረጣል አለ ኤፍሬም ባዬ እናቴ። እናንተ ነው የምትሰሙት?
ሃይፐርፕሌን
ዶክተር ድምፅ ጠፍቶ ነበር
ነው
እስካሁን ጠፍቶ ነበር።
ኧረ እባክህ። እሺ እሺ።
እንደገና ወደ
ዋይፋይ ስለሆነ ምናልባት ይቆራረጣል ማለት ነው። አሁንስ ይሰማል? እሺ። So this support vector machine it uses the margin and some separator or hyperplanes. This hyperplane it uses for classifying the different classes. Like for example, in this class, here it is one group, one class, here it is another class. So whenever the distance between I am saying that between class, it is quite very good. So the distance between class and the distance among between elements or between attributes within a class, or I mean within a data set, within one data set. If it is within a data set, that is very good. Different class 1 and class 2. But the data set, I mean the distance or the difference between different elements in between class, a class, this it should be short. So the distance between class, it should be large. The distance between elements within a class, it should be small. That is a principle of SVM classification. So this SVM classification, it may be used for binary data set like this, or it may be non-binary data sets, multi-classes. If you have multi-class like this, we have 4 classes. So the algorithm can classify like this independently, you see, independently. So that independent classification can be done using SVM. So here it is, you know, the margin, whenever the margin, the distance is very small, that means the data sets are too similar, which is very difficult. Whenever, if the distance between them is very large, then it is quite good for classification or our algorithm. So what type of technique we should use? In such nonlinear data sets, it is very difficult using linear classification. So we have to use this SVM. This SVM, it uses a function which is called kernel. This kernel, it uses for mapping this into another matrix form. This matrix, new matrix. This is new matrix. This is new matrix. It helps for transposing nonlinear data set into linear format. That will be easier for classification. That is, it is called SVM. Is that clear? ግልጽ ነው? Is that clear? ስለ ኤስቪኤም ጥያቄ አለ? ኦኬ። አይ በዛውም መኖራችሁን እያረጋገጥኩ ነው። እሺ So So this so SVM, it may be linear separator or some linear type. If the data is linear, we can say that this is separator is non-linear. It is linear. If it is the data type, the data nature is linear, non-complex data. But sometimes in the real world, it is very difficult to say that the data is really non-complex. Non-complex or non-linear. It is very difficult. Think over that about the data set in telecommunication. Think over about the climate. Think over about the agriculture, productivity. Think over about social media. Do you believe or do you think that can be linear? It is impossible. It is impossible. So it is a SVM on highly dimensioned data set. This is very essential for highly dimensioned. Mean that if the data set like if the data set it is very sorry. If the data set is like, for example, the dimension, highly dimension mean that the high number of dimension, it does mean that it is very complex. So if it is very complex, it is very difficult to use or to apply machine, the usual machine, the usual classifier. That classifier, it is called support vector machine, which is polynomial support vector machine or Gaussian support vector machine. There are a number of SVM types. The one is it is a linear that uses for separating data, but it is non-practical. You see, the data says this black color, this black element, which is grouped as this is the white one, using this linear classifier. So it is not that much practical for our data set if we are in the real world. So we have to use some technique which is called, as I told you, kernel function. This kernel function is used for mapping. There are different kernel functions like polynomial kernel. This polynomial kernel, it uses for mapping into n dimension of data. If it is Gaussian or radial based function, ወይም RBF እንለዋለን. RBF, that is, it uses for mapping into some numbers, some exponential numbers. That is, it is called RBF. And there is a sigmoid kernel that uses into mapping into tonnage. The tonnage maps the data set into a new formats. So which one is good? Do you think that linear is good, or polynomial good, or radial RBF is good, or sigmoid is good? Which one is better? If I asked you to recommend the algorithm, which one is more recommendable for our data sets or any implementation? Which one is good? If I asked you to recommend, like for example, assume that you are my advisors, and are you okay to recommend me as any algorithm is good for any data set? Anyone who can answer this question? Assume that we have different types of SVM, and Alamu, he's raising his hand. Alamu, please welcome.
Okay. When we select algorithm, or when we advise about algorithm, it must be know the data have behavior and the content of the data. After that, we can recommend a specific algorithm for that.
Excellent. Excellent. Yeah. It is very difficult to say that a polynomial type or a linear type or logarithmic type or Arabic type or Gaussian type is better. It is very difficult. We cannot say that because the data nature, the machine type, the data complexity, the number of features, these all affect the performance of the algorithm. So we have to test. Unless we enable us to test and we evaluate, we cannot say that this is better than that. Thank you, Alamu. So you see, this is the result what I bring from my previous work. So here it is, like for example, if you define as a kernel type is linear, you can say that as kernel type is equals to linear. If it is the type is RBF, then you can say that kernel is equals to RBF. And if you say that the kernel type is polynomial, you can say that this polynomial, you see? So in the program, if you change the kernel is equals to linear by RBF, only you can change this linear by RBF. So you can compare and contrast the performance. Like for example, you see this one, it uses a linear type, which is very difficult. Some of the data is just grouped here, and the other group, the red color is grouped here. And here linear kernel. And here is RBF type. You see RBF type, something it is not linear. It is not a straight line. It is some parabolic, depending on the data nature. And here it is a polynomial. As you see, some of the classification, so that we have to compare and contrast the algorithms, the performance of the algorithms, And yeah. And here here it is the one I told you before about the type of the kernel. If it is a polynomial, there is a polynomial. If it is Gaussian RBF, here it is a radial base function below, and there is the one what we have said that it is some sigmoid type. We can say that. And here it is some comparison you can read. So this is also the fifth type, which is very important classification type. It is an association technique, data association technique. What if we cannot use some polynomial types? It is very difficult, so that we have to use some technique. It is called an association. That association it uses for associating different variables. Like for example, there may be a number of variables here. So how we can associate those variables, like P1, P2, P3, something. If you have the different features, like n features, fn feature from f1 up to fn features, how we can associate them? There should be some associations. That association it is called associate based classification. So we have to calculate